Hello everyone, welcome back to my channel Explain Maths. So in this video, I am going to do the factorization using identities, and I have explained the all the standard identities in detail along with the geometrical representation of that identities. And then I have solved exercise 12.2 question number 1 and question number 2. Now this topic factorization I have taken from grade 8 of the NCERT textbook. So let's begin the class. Now first of all, what do you mean by identity? So an identity is an equality which is true for every value of the variable in it. Now what does it mean? So let me take one example and I can explain it. So I have taken here a plus 1 into a plus 2 is equal to a square plus 3a plus 2. Now how I have got this a square plus 3a plus 2? So you have to multiply. You have already studied how to multiply two binomials, right? So you can use that and you will get it like this. Now identity means it is an equality. Equality means equal, which is true for every value of the variable. So whatever value of variable A, you will give it in LHS and RHS, the value will come same. So let's try out. Let me give first the value of A as 2. So if I give the value of A as 2, my LHS will become A plus 1. So 2 plus 1 is 3. 2 plus 2 is 4. So LHS is 12. Now RHS will be A square. So 2 square plus 3 into 2 plus 2. So 2 square is 4, 3 into 2 is 6. So it will give me the value as 12. So you can see LHS and RHS both are same, isn't it? So this is, now I will take another value of A. So let me take the value of A as 1 and LHS will become 1 plus 1, 2 and 1 plus 2 will give me 3. So it is 6 and RHS will be A square means 1 square plus 3 into 1 plus 2. So 1 plus 3 plus 2 will give me 6. So here also you can see LHS is equal to RHS. So whatever value of A you will give, both LHS and RHS will become equal. So that is known as identity because it is a equality. Equality means it is equal. Whatever value of the variable you will get, this condition will hold true always. So now I will explain the few standard identities. So the first standard identity is a plus b whole square. So a plus b whole square, I can write it as a plus b into a plus b. So now let's multiply it. So it will be equal to a into a plus b. I have taken the first term of the first binomial and multiplied with the second one. Same way plus b multiplied with again a plus b. So if you multiply it, you will get a square plus ab plus BA plus B square. So it will be equal to A square plus 2AB plus B square. So this is your first identity, A plus B whole square, which is equal to A square plus 2AB plus B square. Now let's see the geometrical representation of this. So I have taken a rectangle over here, okay, I have taken a square whose measure of each side is A plus B. So this is also A plus B, this is also A plus B. And then I have divided in 4 parts. So my first part, this is a square. You can see the side measure is A, okay. The second one and the third one, this is a rectangle and fourth one is again a square. So I can say from here the area of this complete square, which is A plus B whole square, that will be equal to the sum of the area of all these 4 parts. So let's find the area of each part. So first one is A square. Second one, this is B, this side is A. So this will be AB. Same way this is also AB and this is your B square. So from here I can write A plus B whole square. A plus B whole square is the complete area of the square, which is equal to sum of the area of the small part. A square plus AB again plus AB plus B square, which will give me A square plus 2AB plus B square. So this is the geometrical representation of the identity A plus B whole square. Now let's factorize x square plus 8x plus 16. So x square I can write it as x whole square. 16 I can write it as 4 square. So just now we have studied the identity a plus b whole square is equal to a square plus 2ab plus b square. So a square I got as x square, b is my 4, 4 square is b square. Now let's see 2 into a into b is 8x or not. So 2 into a is x, b is 4. So 2 into 4, 8x. Okay, 2 into 4 into x will give me 8x. So I can write this as a plus b whole square, x plus 4 whole square. So this is the factorization of x square plus 8x plus 16. Now this is the second identity, a minus b whole square. So this I can write as a minus b into a minus b. So let's multiply it. So it will be a times a minus b, then minus b times a minus b. Now let's multiply. So a into a square minus ab, then minus ba plus b square. So from here I will get it as a square minus 2ab plus b square. Now let's see the geometrical representation. So here I have taken a square whose side measure is a. Okay, this side is also a, this is also a. And I've divided in 4 parts such that this part is of measure b and this part is also of measure b. So let's find what is the area of this part. So if this complete side is a and this part is b, so can I say the side measure for this part is a minus b? I am talking about this part. So this is your a minus b. Same way, this is your a minus b. Okay. So the area of this square will become a minus b whole square. And this area only you have to find because this is the standard identity. So this a minus b whole square, if I have to find only this area, it means from the area of this complete square, which is a square, I have to subtract this part and this part, isn't it? I have to subtract this part, which I am marking with red, this part as well as this part. From the complete area of the square having side A, you have to subtract this part, then only you will get the answer for this. So what I am going to write, a minus b whole square will be equal to a square minus. From that, I am going to subtract first this rectangle. So this measure of this side measure is b. What will be measure of this side? It will be equal to a, right? So from here I can write the area of this complete rectangle will be AB. Then I have to subtract this lower rectangle also. So again you can see this side measure is B and this will be, the length will be A. This part is A. So again the area of this lower rectangle will be A into B. Now if you have noticed one thing, in both the rectangle my this part is common, isn't it? And it is getting subtracted twice, from this side also, from this side also. But I have to subtract only one time. So what I will do, as it is getting subtracted twice, so I will add one time the area of that small square, which is b square. This small square is b square. So from here now I can write it will be equal to a square minus 2ab plus b square. So this is the second standard identity. Now let's factorize this question. So here if you can see 4y square minus 12y plus 9. So 4y square I can write as 2y whole square. 9 I can write as 3 square. So let's write it. So 4y square I can write as 2y whole square. 9 I can write as 3 square. Okay, and just now we have studied the identity a minus b whole square is equal to a square minus 2ab plus b square. So if I consider 2y as a and 3 as b, so I have got my a square and b square. Now I have to see this 2ab. So minus 2 into 2y into 3. Now if you multiply, you will see you are getting 12y. 2 2s are 4, 4 3s are 12. So from here I can write this in the form of a minus b whole square. So a is 2y, b is 3. So it is 2y minus 3 whole square. So this is the required factorization. Now this is the third identity, a plus b into a minus b. So let's multiply it. So it will be a, I have to multiply with a minus b, then plus b, again I have to multiply with a minus b. So if I multiply it, it will be a square minus ab plus ba minus b square. So minus ab plus ab will get cancelled out and I will be left with a square minus b square. So this is my third identity. So let's see the geometrical representation of this. So here I have taken a square whose each side measure is a. You can see this, the big one, the purple one, the complete purple one is a square having side measure a. Next, from this I am going to take a small square whose side measure is b. Okay. Now I am going to remove this square having side measure b. So when I remove it, it will become something like this. So what happened from the area of the big square is a square. From there I have subtracted this area of a small square having side measure b. So the remaining area become a square minus b square, right? Because this complete area of the square was a square. From there I have subtracted this small area. So it is a square minus b square. And the measure of this side will be a minus b because this complete measure was a and this is b. So the remaining will be a minus b and this part is a. Now let's see what I have to do next. Now next what I did, I have divided it from this part. Diagonally I have divided it. So this measure is a minus b and this is your b because from here only there was a small square having side measure b. So this is also b. Now after dividing it in two parts, I have rearranged it. Okay, so when I rearranged it, I have got a rectangle. Now how I have rearranged it? After dividing in two parts, this side measure B, I have placed it over here. Okay, I have taken this part, I have flipped it and then this B part came over here. So this is your A minus B. This will remain A because this part was A, right? So this is also A. So now you can see it is in the form of a rectangle, isn't it? It's having breadth as a minus b and length is a plus b. So what will be the area of this rectangle? So from here you can say that this is equal to a minus b into a plus b. And from where you have got this? You have already seen in the previous slide, right? The area of this part, this remaining part, when you have taken out this smaller square b having area b square, this remaining part area was a square minus b square. That only you have rearranged and I have got it in the form of a rectangle. So from here I can say a minus b into a plus b is equal to a square minus b square. So this is your third identity. Now let's factorize it using the identities which we have studied just now with the help of the standard identities. So here you can see it is 49p square minus 36. I know that 49 is a square of 7 and 36 is a square of 6. So I can write it as 7p whole square minus 6 square. And now you can see it is in the form of a square minus b square, isn't it? Where a is 7p and b is 6. So it can be written as a plus b, a minus b. So I have to write it as first a plus b, a is 7p and b is 6. So 7p plus 6 and 7p minus 6. So you can see it is very easy. Just you have to identify that which identity you have to use. Okay. And this chapter is like if you do more and more practice, it will become very easier. Okay. As soon as you see the question, immediately it will click in your mind that which identity we have to use. Okay. Let's move to the next question. Here it is a square minus 2ab plus b square minus c square. So I can see from this first three terms only that it is nothing but it is the identity a minus b whole square. We know that a minus b whole square is a square minus 2ab plus b square. So this is a minus b whole square. A minus b whole square is a square minus 2ab plus b square. And then I am left with minus c square, right? So again, I can use this above identity which I have used in the previous question. A square minus b square. This complete I have taken as a square and this is your b square. So further you can write it a plus b and a minus b. So a plus b. So a is now a minus b plus b means plus c, and then a minus b minus c. Now you have to mention the identity also. Okay, in many schools they mention that you have to mention the identity which you have used while solving the question. So you can mention it even in the previous question also you can mention. I have written the identity in the at the top only. Now moving to the next question. Factorize m to the power 4 minus 256. 256 I know it is a square of 16. M to the power 4 I can write as m square whole square. So this I can write it as m square whole square minus 16 square. So now you can see your a is m square and b is 16. So again you have to use a square minus b square. So it will become a square plus 16, a plus b, and then a minus b. So m square minus 16. Okay, and please mention the identity which you have used. Now next, if you can see m square plus 16, I cannot factorize it further. But if you see the second part of it, m square minus 16, again 16 can be written as 4 square, isn't it? So I can write it as m square minus 4 square. So this further you can write as m square plus 16. Now again you have to use the identity a square minus b square where your a is m and b is 4. So you can write a plus b which is m plus 4 and a minus b which is m minus 4. Now you cannot further reduce it. So this is going to be your final factorization. Now this is also one more identity x plus a into x plus b. So this you have to multiply. So if you multiply it, it will be x into x plus b, then plus a into x plus b. Now let's multiply. So x into x will give you x square plus bx plus ax plus ab. Now if you see the second and third term, x is common. So I will take x common. So it will be a plus b. I have just changed the order. Ax, x into a is ax and x into b is bx plus ab. So this is your next standard identity. Now let's see the geometrical representation. So here I have taken a rectangle whose length is x plus b and width is x plus a. So the area of this rectangle will be length into breadth, which will give me x plus a into x plus b, right? Area will be x plus a into x plus b. So I can say that area of this rectangle will be equal to the area of these small rectangles or a square. So first one, if you see this green part, this is a square because this length is also x and this is also x. So area of this part will be x square. Now if you see the purple one, this measure is b and this length is your x. So the area of this will be bx. Now yellow one, this measure is a and this is your b. So area will be ab and this will be ax. Okay, this is your ax. I'm writing here. So this is your ax. Now it is clear, I think. So now I can write it as area of the complete rectangle will be the sum of the area of the small part. So it will be x square plus ax plus bx plus ab. And again you can see in the second and third term x is common. So I can write x into a plus b plus ab. So I have covered four identities. First was a plus b whole square, which is equal to a square plus 2ab plus b square. Then a minus b whole square, which was a square minus 2ab plus b square. Third was a square minus b square, which was equal to a plus b into a minus b. And this is the fourth one, x plus a into x plus b equal to x square plus x into a plus b plus ab. Now let's factorize x square plus 5x plus 6. So if you can see here, 6 is not a square of any number. So we are not able to use the identity a plus b whole square and a minus b whole square. Even a square minus b square identity also I cannot use here. Okay, so what I will do, just now we have studied the other identity, right? X plus x square plus a plus b whole x plus ab is equal to x plus a into x plus b. So what we have to do, we have to split this middle term in such a way that the sum will be equal to 5. Okay, and the number which you are going to split this 5, the number if you multiply you should get this number 6. So it means a plus b should come as 5 and a into b should come as 6. You have to find out two numbers whose sum will give you 5 and whose product will give me 6. So I can see that if I do 3 plus 2, I am going to get 5. 3 plus 2 is 5 and 3 multiplied by 2 will give me 6. So from here I can write this as x square plus 3x plus 2x. See, 3x plus 2x will give me 5x plus 6. Now from the first two term I can take x common, so it will become x plus 3. From the last two terms, I can take 2 common, so it will also become x plus 3. Now, in both the term, I can see x plus 3 and x plus 3 is common, so I will take it out. And then I will left with, in the first term, I will be left with x, and in the second term, I will be left with 2. So from here, you can see that my answer is x plus 3 into x plus 2. So it is in the form of x plus a into x plus b, where your a was 3 and b was 2. So this question I have factorized using the fourth identity. So first you have to try whether you can do it using the first three identities which I have explained. If not, then you have to use the middle term splitting method, and then only you have to factorize. Let's see the next question. Find the factors of y square minus 7y plus 12. Again, if you see here, 12 is not a square of any number. So I have to use middle term splitting method. So I have to find two numbers whose sum will give me minus 7 and whose product will be equal to 12. Okay. So I know that 4 into 3 is 12. And minus 4 and minus 3 if I add, I will get minus 7. So I can write it as y square minus 3y minus 4y plus 12. Now you have to check. See, a if I take, a I am taking minus 3 and b I am taking minus 4. So when I add minus 3 plus minus 4, I will get minus 7, isn't it? And when I multiply minus 3 into minus 4, I will get plus 12. So this is the required value for a and b. Now from the first two term, I can take y common. So it will be y minus 3. From the last two term, I can take minus 4 common. So it will be y minus 3 again. Okay, don't get confused here. Here is minus, so minus 4 into y will give me minus 4y, and minus 4 into minus 3 will give me plus 12. So again, if you see in both the term, y minus 3 is common, so I will take it out. So from the first term, y will be left, and the second term, minus 4 will be left. So this is the required factorization of the second question. Now next do the third one. Find the factors of 3m square plus 9m plus 6. So again, if you can see over here that 6 is not a square of any number. Moreover, in all the three terms, if you can see 3, 9 and 6, the highest common factor is coming as 3. So first I am going to take 3 common. So if I take 3 common, it will be m square. 3 into 3 will give me 9 plus 3 into 2. Isn't it? So this is, I have to factorize now m square plus 3m plus 2. So again what you have to do, you have to find two number whose sum will be 3 and whose product will be 2. So product will be 2 means it will be 1 into 2 only. So A if I am taking as 1 and B I am taking as 2. So A plus B will give me 3, A into B will give me 2. So it means I can write it as m square plus m plus 2m plus 2. You can see m plus 2m will give you 3m. Now take common. So From the first two term, if I'm taking m common, I will be left with m plus 1. From the last two term, if I take 2 common, I will be left with m plus 1. Isn't it? Now, again, I can take m plus 1 common. So, from the first term, m will be left. From the second term, plus 2 will be left. So, this is your required factorization. Now I'm going to start with exercise 12.2. So this is the first question. Factorize the following expressions. And the first expression is a square plus 8a plus 16. So if you can see here, a square I can write as a whole square. 16 I can write as 4 square. So a square and b square is there. Now I have to just see whether it is 2 times a into b. This value will I get if I do 2 times a into b. Now my b is 4, a is a itself. So 2 times a into 4. So 2 4s are 8. So I am getting this. So it means I can rewrite it as a whole square plus, now this is your 4 whole square. Now I can write it as 2 into a into 4, right? 2 4s are 8. So 8a. So this is equal to a plus 4 whole square, and you have to mention the identity also here. So you can mention a square plus 2ab plus b square is equal to a plus b whole square. Now second one, here it is p square minus 10p plus 25. So you can see p square I can write as p whole square, 25 I can write as 5 square. Now this minus 10p, can I write it as minus 2 into a into b? Your b is 5, right? So let's see. So this is your p whole square. This is 5 whole square. So if I am going to write it in the form of 2ab, 2 into p into 5. So I am getting minus 10p. It means I can write it as p minus 5 whole square. And here I can mention the identity a square minus 2ab plus b square is equal to a minus b whole square. Next, third one, 25m square plus 30m plus 9. Now 25m square I can write it as 5m whole square. 9 I can write it as 3 square. Okay, now let's see 2ab. 2 into 5m into 3. When I multiply it, I am getting 30m. So this I can write in the form of a plus b whole square, which is 5m plus 3 whole square. And please mention the identity. Fourth one, 49y square plus 84yz plus 36z square. So 49y square I can write as 7y whole square. 36z square I can write as 6g whole square. Now let's see 2 times a into b. So 2 times 7y into 6z. So 2 7s are 14. 14 into 6 is 84yz. So this I can write as 7y plus 6z whole square. So here all the questions were based on either a plus b whole square identity or a minus b whole square identity. Now let's move to the another question. Now question number 5. 4x square minus 8x plus 4. So first of all, if you can see in all the three terms, 4 is the highest common factor. So first I will take it common. I will take 4 commons. It will be x square minus 4 into 2 will give me 8. So 2x plus 4 into 1. So this will be 4 times. Now 1 I can write it as 1 square, right? 1 square will give me 1. Now this is also in the form of 2 into a into b, because 2 into x into 1. So this I can write it as 4 into x minus 1 whole square. I have used the identity a minus b whole square. Next, question number 6. 121b square minus 88bc plus 16c square. So I know 121 is a square of 11, 16 is a square of 4. So let's do it. So 121b square I can write as 11b whole square. 16c square I can write it as 4c whole square. And this will be minus 2 into 11b into 4c. So let's check it quickly. 2 into 11 is 22. 22 into 4 will give me 88. And b into c will be bc. So this I can write it as 11b minus 4c whole square. Again I have used here a minus b whole square identity. Now seventh question, L plus m whole square minus 4lm. So first I am going to expand this L plus m whole square using the identity a plus b whole square, which is equal to a square plus 2ab plus b square. So let's write. So L square plus 2 into L into m plus m square minus 4lm. Now you can see 2lm and minus 4lm both are like terms. So I can group it together, isn't it? And 2lm minus 4lm will give me minus 2lm. Plus 2 minus 4 is minus 2. So minus 2lm plus m square. And you can see now this is identity a minus b whole square, where your a is L and b is m. So I can write it as L minus m whole square. So L minus m whole square is L square minus 2lm plus m square. Next question, a to the power 4 plus 2a square b square plus b to the power 4. So a to the power 4 I can write it as a square whole square, and b to the power 4 I can write it as b square whole square, isn't it? And this will be 2ab, 2 into a square into b square. So this is based on the identity a plus b whole square. Now your a is a square and b is b square. So a square plus b square whole square. So this is the factorization. Question number 2, factorize 4p square minus 9q square. Now you can see 4p square I can write as 2p whole square. 9q square I can write as 3q whole square. So this I can write it as 2p whole square minus 3q whole square. Now it is based on the identity a square minus b square, where your a is 2p and b is 3q. So which you have to write as a plus b into a minus b. So let's apply it. So a plus b will become 2p plus 3q, and a minus b will become 2p minus 3q. Next question, 63a square minus 112b square. So 63 is not a square of any number. Even 112 is also not a square of any number. So it means I have to find the HCF of 63 and 112. Now 63 and 112 both comes in the table of 7. So I can take 7 as my factor, common factor. So 7 times 9 will give me 63. So 9a square minus 7 times 16 gives me 112. So 16b square. Now you can see 9a square I can write as 3a whole square. Isn't it? 3a whole square will give me 9a square, and 16b square I can write as 4b whole square. So now it is again in the form of a square minus b square identity. So I can write it as a plus b, so 3a plus 4b, and a minus b, which is 3a minus 4b. Now third one, 49x square. 49 I can write as 7x whole square. 36 I can write as 6 square. Again I have to use a square minus b square identity. So it will be 7x plus 6 and then 7x minus 6. Last one, 16x to the power 5 minus 144x cube. So here what I am going to do, I can take 16 is a square of 4, right? But x to the power 5 is not a square of any number. Same way x cube is also not a square. Even the power is an odd number. It cannot be a square. So what I have to do? First I have to take the common factor. So the common factor is 16 and the variable also present in both the terms. So the lowest power of x is 3. So 16x cube I am taking common. So I will be left with x square. And here 16 into 9 will give me 144. Now I can write it as 16x cube, and this will be x whole square minus 3 whole square. So now again it is in the form of a square minus b square. So I have to write it as a plus b and then a minus b. So this is the factorization. Now question number 5. It is L plus M whole square minus L minus M whole square. So in this question, you can take A as your L plus M. Okay, this is your A and this is your B. Now I can use the identity A square minus B square, which is equal to A plus B into A minus B. So let's use it. So A plus B. A is L plus M plus B. B is L minus M. And next you have to use A minus B. So L plus M is your A minus of L minus B. So it will become minus L plus M. Now you can reduce M and minus M, and from here also you can reduce L and minus L. It will become 0. So it will be 2L into 2M. 2 into 2, 4LM. This is the factorization. Now you can do this factorization in another way also. You can use A plus B whole square and you can expand it. Same way you can use A minus B whole square and expand it. And then you can simplify. Okay, like that also you can do. I have used this identity A square minus B square. Next, 9x square y square minus 16. So 9x square y square, I can write it as 3xy whole square, and 16 is the square of 4. So again it is in the form of A square minus B square. So A plus B, A minus B. So 3xy minus 4. Next one, x square minus 2xy plus y square minus z square. So if you see here, this is your identity A square minus 2ab plus b square. So I can write it as x minus y whole square minus z square. Now it is of the form A square minus B square, where this is your A and this is your B. So A square minus B square means A plus B. So A is x minus y plus B is plus z, and then A minus B. So A is x minus y minus of z. Next, 25A square minus 4B square plus 28BC minus 49C square. So this question is little complicated. If you see here 28BC and your B and C part is over here. So if I consider this last three terms, I may get identity either A plus B whole square or A minus B whole square. So let's try it out. So it will be 25A square. I have taken minus common. So it will be 4B square minus 28BC plus 49C square. Now why the sign have got changed? Because outside the bracket there is a minus sign. So inside sign will change. Now 25A square minus 4B square, I can write it as 2B whole square. 49C square, I can write it as 7C square. Now minus of 2 into 2B into 7C. If you check 2 2s are 4, 4 into 7, 28. So here I can see now it is in the form of A minus B whole square, which is 2B minus 7C whole square. And 25A square I can write it as 5A whole square minus 2B minus 7C whole square. Now again it is in the form of A square minus B square. This is your A and this is your B. So you have to write A plus B. So A is 5A plus 2B minus 7C and then A minus B. So 5A minus 2B plus 7C. So this is your required factorization. So that's all for today's class, and if you like my video, please subscribe my channel and share with your friends also. Thank you.